Hello world. Today we're going to discuss the structure and its configuration. So let's start with the topology of it. Start off with, at the time the Nile River would have come from the African plains to the Mediterranean Sea. Coming from south to north, one of the few rivers that actually runs south to north. And this would be west and this would be east. And it comes from south and runs to the north. Okay? Like many rivers, no exception, it winds back and forth. You don't have to trust me. You can go look on Google. You can pull up topology maps and you can see where the riverbed ran. And according to what I can tell, it was about 20 feet above sea level at this point, and that would have been the base of it. The mouth of it seems to be closer to 25 to 27 feet, which would be the, if I'm going to do this correctly, so just when I have brand new things and they bleed like that, so let's clean that off. The Sphinx would have been at the elevation, the base of the Sphinx would have been basically saturated in water, is my belief, the way the system works. And that one sat at about 25 to 30 feet in elevation, making the sea level, or the river bed, about 10 feet deep. So the three structures, the primary structures, are the Great Giza Pyramid, the one they love to discuss, the one that has all the cool internal guts, and it sits about 60 feet in elevation above sea level. The second structure, if I can do it correctly, about here, and it sits about 65 feet in elevation above sea level. And the third structure sits about and it sits at about 70 feet above sea level, like so. Now, one other important thing is there is a hill, I'm not going to call it a mountain ridge, that runs about this way, with its highest elevation is about 105 feet, and it runs to about 80 feet, and it kind of swoops around a little bit more, and then droops down pretty quick. You can, again, pull up topology maps. Don't have to make any of this up. This is the system. Now, other important pieces, approximately here, is the Osiris shaft, and it sits at about 40 feet. The top of it, the entrance to it, sits about 40 feet in elevation above sea level. And I guess those are going to be the important pieces. Oh, yeah. Right about here is a opening. I don't know if it technically has a name on your tourist maps, but it is where people are no longer allowed to get into, but in the past people have gone down into the caves under Giza, which I will suggest at the time of the operation were aquifers. These are not the same as the chiseled conduits that litter the Giza Plateau that Bren Forrester and many other people have discussed, Johnny West and half a dozen others, even Edward Nightingale, which, by the way, if you want the best survey of it, I was just going with Edward Nightingale. You can get it in his book. He doesn't, to my knowledge, from what I've seen, discuss it in elevation. He's looking at it top down, but it still gives you a really good impression. Many of the other numbers in the past, I think, were manipulated so you don't see the correlations. And I'm going to discuss a bunch of the correlations because once you see them, it's hard to unsee them. So now we're going to take this whole plateau and we're going to lay it down north to south, and we're going to look at it this direction. Now we'll come back to this, but so this is north and this is south. And this area is approximately a mile. So we're talking a pretty large system, a Halliburton-sized project. Now the primary structure, like I was saying, sits about 60 feet above sea level. And this is sea level. No, this is not linear. if I did that, since the internal guts of the Great Giza Pyramid only encompass the bottom 20% of it, everything would be mouse type, and I'm not going to do that to you. It sits at 60 feet above sea level, as we discussed, and if it was drawn nice and straight, goes up 490 feet, so that it would go to 550 feet in elevation. The second structure sits, like we said, at 65 feet above sea level, and it goes up 480 feet. So if we were to play with this, it would be 5 feet shy of that. But in reality, this one is truncated at the top approximately 30 feet, so it only goes up 450 feet. They like to say 452, I think, is the exact number they work with. And we'll get into those details in a minute. This one is the one that is smooth at the top with the little tail on that one side. I like to call it a grounding plane, or a ground, but we'll get to that when we play with it. And this one sits at approximately, like I was saying, 70 feet above elevation, and it today goes up 215 feet. So if I was actually to draw it to this scale, it would actually be way down here, but I'm going to do it here right now. Forget these numbers for right now. Just play with them, because I said if I try to do it to scale, things are going to be mouse type. So now, this 215 feet, it's a weird number, but I'm going to suggest to you that if we look at the casing stones that are at the bottom of this, and we were to draw from the casing stones up and down, it would actually be 220 feet if it was allowed to be a nice smooth surface, which I'm not saying it ever was, but if it was drawn to be a nice smooth surface, that would be 220 feet. If you double that, that's 240 feet. This one is actually 10 feet lower, that would be 250 feet. It's half the size of this if we went from the base here, half of where this is to there is the size of this, practically to the foot. And I'm going to suggest to you, since they really didn't make very many mistakes, it's probably to the millimeter. But that's a whole nother story. Now this structure, about 10-15 feet in elevation, it jots in about half a foot, and then about 20-30 feet up. And you can look at this. You can take your little Google guy and drop them on the plateau, and you can look at it. They're Panoair or whatever it is, where they were allowed to fly drones on here and get stereo pictures of really cool drone footage. You can see, in fact, it's you can get to it from the links on my website. You can see where it steps in, just like this one steps in at the 35th level. They call it the magic 35th level. There's a ring around there at approximately the same elevation, and we can bicker. In fact, I'd love to get somebody to actually get me the exact elevation so I can tell, is it exactly, or is one of them a row above or below. This one also, but it steps in at a lower elevation, goes up, steps in again, and depending on which side you're on, there's actually a division there where it cuts into the structure, and then if you notice up here at the top, they like to, if you look at it, it's kind of like so. And I said there was that little grounding plane there. We'll get into what the surface of the structure is doing with brush discharge static electricity and how it quarantines and manipulates it as we discuss how the system functions. But right now we're going over the setup because it is kind of important. 250 feet. This goes up to, from the top to where it deviates is a consistent, the entire thing is a consistent step. It's very fixed, regular, it's not real, I guess it would be symmetrical, but it's consistent, I guess is the word I'm looking for. At here, there's smaller steps until you get to this section here where it goes from smaller steps to larger steps till it gets down to here where it's even larger steps yet. Now this one is extraordinarily unique. In fact, there was a gentleman back in the 1800s, and then somebody else recently in the early 2010-ish area did it with a stereo drone to get a much better reading. But it has a very unique sweeping pattern to it. And I go over that in my pyramid phrenology video. Phrenology, reading the bumps on people's heads, phrenology, reading the surface. Get an idea? Anyway, and it has a sweeping pattern to it. And again, that is designed, as I was just suggesting, the brush discharge static electricity, the stuff that on a dry, windy day makes it so you can snap your finger on a doorknob. The same stuff that reason why you put anti-static cling sheets in your dryer so you don't get static cling. That stuff. It takes and quarantines that and pushes it to the top. The lack of a top there causes it to act like a big Van de Graaff generator. And then that is utilized within the structure. Now, let's draw this more to scale now that we've gone over that and discuss a little bit here. So this at 215 feet would actually be way down here. And you'll notice that this elevation here is the same elevation, and I suggest it's not a mistake, that the conduits that come from what they like to call the King's Chamber come from. And I suggested that this is way down at down here. But again, if I draw it to scale, we're going to be dealing with mouse type. Maybe when I get into a CAD, we can blow it up and you can actually look at it. In fact, if there's anyone that wants to play with a CAD, I'm sure even if we did it in Minecraft, I don't care. It would still function. But it's down here. That would be the King's Chamber with these two conduits. The northern conduit is the southern conduit is the only one that breaches the structure, and it breaches the structure, from what I understand, at about the 203rd level. This one breaches. Yeah, this one breaches. It doesn't breach. This one comes to, but it does not breach, and it would have come to about the 204th. I actually think it's the 201st and 202nd. It's up there. Again, we can bicker off because it depends on where you count. And down here, where the again, if I did this to scale, it would be annoying. But the 35th level down here, which is on par with the top of the Queen's Chamber. Okay. Where's I going with that? Now I lost myself. The 35th level there is on top of the par with the Queen's level, with the conduit that comes over. Grand Gallery being in here, okay, which goes all the way down to this level. And again, this is why I'd rather have in CAD. You got what they like to call the antechamber there, the pre-chamber, okay. It goes over to there. This actually goes up to the same height as there, and this extends up like so. And they like to call those the relieving chambers. We'll get into that. Down here, it extends down. There's the conduit that comes to us, where I was going from. At below the 35th level, about the 19th level, there is the steps here get to be rather small. So do you count them as the average size, or do you count them as the small size? So the 35th level, right down here, you can see that down here these steps are a little bit smaller than here. These ones are larger. So larger, smaller. So how do you actually calculate when you get up to the 200 and something level? So we'll just work with the suggestion, fact, anomaly, that the apex of this is on par with where these conduits go to the surface. Now within the Queen's Chamber, there are also conduits, and I'm going to refer to these more often as my suggestion for the room. This would be the combustion chamber, this would be the condensation chamber, and this would be the arc chamber. They also have the area where it goes down to the pit, which would be at ground level. I like to call that the grotto. It has a very, very unique shape. In fact, I've done videos specifically on that, and it's very unique shape. and what it does and how it functions, and we can get into that as we go on. This is what they like to call the descending shaft. It is approximately 170 feet in length, and it goes down about 50 to 70 feet below the structure. So it goes down to about, if this sits at 60 feet in elevation, it's going to go down to 20 feet in elevation. So it descends down to the same level as the elevation of the base of the Nile River. No coincidence. We'll get into that later. So it goes down, comes over, you've got the, they like to call the pre-chamber and then the primary chamber. And again, this isn't to scale because this is more to the middle, blah, blah, blah. Got to give me a little bit of artistic license here. Okay, this protrudes down just a tiny bit lower. You got that, like they like to call the dead end shaft. It's fine. It's a dead end shaft. Now this also has, it was in that image that I just showed you, a very unique shape. It is, again, not something to be toyed with, and it is very awesome. You can pull up the images, look at it for yourself. I can't really do it justice on this small scale. There's a pit in here. Okay, this is the one of the few places that it actually touches earth. Everything else within here is in a limestone bath, a limestone construction. This area in the grotto, they like to call it, is the only other spot where it touches earth. Everything else, again, is in a limestone bath. However, from here up, it is the pyramid structure. From about halfway through it down, it is in a limestone bath, with the exception of the pit, which I think is about 20 feet deep there and about 20 feet deep here. So this pit goes down 20 feet below what would have been the base of the Nile River outside the structure. The area that they like to call the Osiris shaft, which I said sat at about 40 feet in elevation, would have started here because it comes, it is in front of this structure. We could discuss that on it, and sits there. It protrudes down another 90 feet from there. So 40 feet in elevation plus 90 feet would be negative 50 feet. That is where it touches the water table. That, I'm going to suggest to you, is the ground of the system. The system is completely isolated from the nature as much as it can be, and this is the only spot within the structure that it goes down below the water table. The water table, the Nile River, which I said sat at 20 feet. So if this is 40 feet there, and this is 0 here, 20 feet in elevation here would have been where the base of the Nile River sat, same elevation as this, and then from there it protrudes down another, if I do my math right, another 50 feet, bringing us down to negative 50. So it is 50 feet below the base, the bottom of the riverbed of the Nile River, and this protrudes down about 20 feet below the riverbed of the Nile River. Now, in this structure, it also goes down. It doesn't go down as deep. It goes down on par. The exact numbers, I can't yet. Haven't got specifics. But when you look at it, what's really most important as, on this side of the structure, there is a conduit that comes in, comes up, goes down, and then plays with the stuff on the inside of here. We'll get into that. On the outside of the structure, approximately here on the north side is a pool. If you notice, there is a conduit on this side that goes down. I'm going to suggest to you it goes over. And this side of the structure, there is, I was telling you how it's, the whole plateau is on an angle. So with the ground level coming up from here and going up across there, they had to cut into the side here to allow for a pool of water, and then the conduit, which when this water is filling here, would come up out of here and join with the pool over here, which is located right there. So that would allow the waters in here to short to the waters there. And this structure, for the most part, is dry on the outside of it, with the exception of the pool there, and at a like elevation on the east side, where they like to suggest there was a causeway, you notice there is a bunch of stuff over here. That is going to be a manipulated pool. It's not part of the system, it's maintained, we'll get into that, but it is at an elevation such that this conduit that comes out is going to be just a few inches under the water line, and that's going to seal the system when we get into how it's doing and what it's doing. But that water line will seal the system. You say, how did it maintain that? Well, remember how I suggested there was the conduit about 90 feet in elevation that comes out from up there? Now, it doesn't look like it's very high here, but it's going to come out and it's going to run down from the higher elevation down to the lower elevation. And when it runs down, a couple of things are going to occur. Number one, if you look at this wall on the west side of it, you can again take your glue guy and drop them there. There's a lot of other openings. There's about 2 or 3 of them, some of them very large. Now, the size of it, I think, is more part of the communication than the water flow, but they are there, and the waters would have come into the system at an elevation of approximately 70-75 feet in elevation and spill into the pool. So it didn't flow into it, it spilled into it down a waterfall. Again, keeping this system in isolation from the rest of nature. And on the south side of the structure, east side of the structure, my fault. East side of the structure, there's a more stuff over there. We can get into the manipulation of how this is laid out, but this is going to be the spillway. And I'm not quite sure if the waters, I feel that they would have put a pile of sand here to allow the waters to scoop around to the side, to join with that, and that would be the spillway that would go down. Now, the spillway actually splits. If you look at the conduit, it's kind of at a little bit of an elevation, with the Osiris shaft thing being on this side of it, and this side of it here actually goes down and kind of joins with yes, you need to, if you were to take a tanker truck and dump a jump of water there, take your Google guy and drop it, you notice there is a channel that runs down from there. You can visually see it. If you imagine just dumping gallons and gallons of water, a tanker truck of water, just imagine the water running down. It's going to run down, and it's going to run over the wall of the Sphinx, which is why it has all that erosion that exists there. It compensates for the erosion, and then join into the Nile River. That is going to be one of the ways that the water comes out, but the primary pressures within the structure are from the waters coming from this higher elevation that are going to act like an artesian well from the higher elevation of the river through the conduits and coming out here and spilling down into the system. Now, they may have manipulated it. They may have an Archimedes drill or whatever you call it to pump it up. You know, maybe they had thousands of people with buckets. I don't care. The water came from a higher elevation of approximately 90 feet down into the system. This maintains the pressure of the system. Right here would be the water level of the system, would then flow out through that conduit or spillway I was suggesting, and then down. Now, when it runs down, it does 2 things. Number one, this water shorts with the Osiris shaft, which then shorts to ground. This is the ground for the entire system. And the other side of it, when you look at it, goes down and then proceeds to join with the conduit that comes out where there's, I don't care what they call it. You can put your Google guy there, and there is an area where when it runs down, it drops, and then the Sphinx is at the elevation behind it, to the north of it, where the Sphinx is sitting right here. Okay, and a little Sphinx guy with those little ears. Okay, little tail there. The water would spill into here, down into the Nile, with the Nile being, at that elevation. This would again allow the water to spill out, the overflow to spill out, but not short to the Nile River. It does not short to the Nile River. When the water comes in, it does not short to nature. The system is quarantined from nature in a big limestone bath. Manipulated, engineered limestone bath. Now, what are they doing? I'm going to try to give you this in a nutshell, and then I can expand on it in other videos. I have no problem answering any questions either. And if somebody has they think I've made a mistake, please, I've got pictures, I got photos, I got facts. I'm not making anything up. Static electricity within the system here, which is attempting to get to natural ground here within this system, which is done through all the conduits within the system. As the system grows, I'm going to suggest to you that it creates an oxygen bubble, not just air, an oxygen bubble, again quarantining this system. This energy still wants to get to ground, but because we lock it off, we can discuss how this whole system is working, but it locks it off. This energy wants to go somewhere. Within the Osiris shaft, there are lots of very unique configurations. Okay, I'm going to show you this real quick. Okay, it says drawing. I'd rather have pictures or a CAD. Somebody go down there with a stereo drone and give me a nice picture that I can print out on a 3D scale and show it to you and pull it apart. That would be great when it happens. Don't have it just yet. But this structure here, it jots back and forth. It has areas where it goes down, comes up like that, and then goes down again. Okay? That is designed as little pressure bubbles within the system so that the water, which eventually will be becoming heavier and heavier. What's heavy water? I say this to people, they give me a deer-eyed look. H2O is the stuff we drink all day long. We call it H2O now. 50 years ago, probably people didn't know it was actually two gases unless you actually took the time to go to college. But H2O, separated on its respective gases, takes approximately 1.23 volts of electricity, and then it separates into H2 and O2. Now, out of all the water in the world, statistically, 1 out of 6,800 droplets of water is, it'd be nice if I drew that so people can see it, right? Approximately 1 out of every 6,800 droplets of water is actually D2O, deuterium. What's deuterium? Well, don't look at your normal periodic table. You got to look at the periodic table that kind of looks more like this, with hydrogen and lithium and and it expands out like a cone. Okay. Do I have a picture of that? No, I don't. I should, but we'll do that in another video. But it is the more expanded periodic table. People in college will know about it more than people in high school. But you can find pictures of it. It's a very complicated thing. Hydrogen has isomers, isotopes. I forget which one is which. But you got deuterium, and then you got tritium, and then there's one other, quadridium or something, which is your hydrogen with your electron, hydrogen proton with your electron, hydrogen proton, that's a neutron, 2 neutrons with your electron, and the quadridium is 1 proton, and I guess it's got to be 3 neutrons and your electron. Okay? Now, this one will actually break into helium, He2, and I think it then drops to deuterium. The way it splits when when it goes, this is slightly radioactive, tiny bit radioactive. And where does it come from, the tritium? One out of every, like, I think it's 7,200 droplets of deuterium is actually tritium. Okay, and I don't know the number to actually get to quadritium, but it's probably one out of the even a bigger number. So it's rare, but it exists. It does exist. It is on the periodic table. It's not on the periodic table. Kind of. It's an element. It's not on your high school periodic table. It's on your college periodic table. This system is designed, the way it's working, the way it is separating, we didn't get into the details, but it's separating your hydrogen and your oxygen. The oxygen vents out the system. When it vents out the system, when it goes through this system, I have a video of the system down under, kind of details how it's creating a little kickback pressure pump. Not the way John Cadman suggests, but it is the reason why he found evidence of cavitation within the subterranean structure. But it is designed to give it a little kick every now and then, something which will take the status quo and give it a little oscillation, causing a bunch of the reactions to work. You want to call it the heartbeat of the system? I would love to call it the heartbeat of the system. System's working, every now and then it does a little kick. Why does it do a little kick? Because in that subterranean system, when it meets the other shaft, and you can look at this, I'm not making any of it up. In fact, I can show you on this one drawing, which I didn't make, somebody else did. You see right there, okay? There's a little kick, the little tooth there. Now what that does is the way the system is designed. You've got a smooth section with a little tooth, and then you've got what I call the stucco section, and then you've got the pre-chamber. The gases in this section are being separated in here. And this tooth is only about an inch, and this is about 20 inches. So this is not to scale, but I'm drawing it so you can see it. What will happen is the oxygen within the system will catch in this tooth and will grow a bubble across the bottom here. And as that bubble grows, let's go ahead and make it green, just like the oxygen tanks that you get in the hospital. Okay? It's growing this bubble. And when it gets to here, when that bubble grows, eventually that bubble will break here. And as the bubble goes up, the water swishes down until it hits where it can't push anymore. And you'll notice when you look at pictures from the 1800s, before they went in there and cleaned it up for tourism, there was piles, approximately 4 of them between here and here, of sand. And that sand is where that pressure pump would echo through the system, the heartbeat of the system. And there's also piles of sand that you can see again. In fact, you can still see the evidence of those pumps, even from videos that I saw from the early 1900s, because, early 2000s. 2010, it's actually, I have a video from 2015 where you can still see it. That is on my, in fact, if you go to GoPro 2015, GoPro 2015.giza.ws, it links to a YouTube video, a guy named, I think it was Anthony or Turo or something like that. He went down there with a GoPro, and you can still see evidence of those condensations of the sand where the consistent pump, the consistent pressure oscillations left deposits of sand. You can still see that even today. Brent Forrester also has a good video on that. Well, he doesn't point it out, but it's in his video. 34 minutes into it, I think. His video, Lost Technologies of the Ancients or something like that. It's about 5-6 years old to date, 2014. Maybe it was more, maybe a decade. I'm losing track of time. It's approximately maybe a decade. It was I think the 2018-ish is when he put that video up. You can find it. If not, send me an email. I'll send you a link. I'm not trying to lose that. Actually, I have that at tech1.giza.ws. Giza.ws and Tech 2, because it's divided into two parts. In fact, the second part is also good, because that one is where they show that big battery that they walk through, that they like to call the Serapeum, which I will tell you is a brine water, saltwater battery. And it's where some energy was stored, electricity, energy, pressures, whatever you want to call it. It's a huge one. They walk through it. They leave them scratching their head. If they look at it and they pretend it's more like a tabletop, you'll notice it's a battery. But when they're walking through it, they don't realize it because of the scope of the project, and they can't wrap their head around the fact that these guys had technology that we still are catching up on. Anyway, where was I? Oh, yes, the pumps in there. Now this in here is designed to lock the gases so that water can't go up and gas can't go down. It's like a little vapor lock, pressure lock, which will allow the hydrogen, let's make hydrogen red, just, which goes out the holes that are drilled in the wall, southern wall of the grotto, comes up into the top of the relieving chamber where they find the dust, seeds, and the shells that they can't account for. I will suggest to you it was impurities in the water that was carried up through the gases and deposited where the gas comes into the room and hits a less dense area where it's not coming through the conduit, and then the impurities fall out, and over hundreds of years you get all these seeds and shells and dust, which are pieces of bug wings and stuff like that, shell carcasses and stuff that are impurities within the water that comes into the system. Now the where can I expand? I want to expand, but I don't want to make this too complicated. I break down all the pieces. This is the structure. Once you understand what's going on. Oh, where was I going? In the Osiris shaft at approximately the first level, which is like 20 feet underground, which would put it at approximately the same elevation as the river outside of it, since it starts at 40 feet above the ground level. 20 feet down is the same elevation as the river. There's a spot where there are two conduits that go northish out of the structure. And when they go northish out of the structure, northish out of the structure, one of them takes like a beeline directly for the Great Giza Pyramid. I'm going to suggest to you, and we can prove it later, that it actually interfaces with the conduit that comes out of the north side of the Queen's Chamber. That is because when the structure is working, when it's growing, the static electricity is quarantined to the surface of the all the water vapors within the structure, and as they condense within this room, the room I call the arc room, they will eventually jump out of the water when they reach saturation. And they are again trying to get to ground. They are attempting to get to the conduit that goes to the Osiris shaft. The only ground, and this is, like I said, it's quarantined. This is the ground to nature. It's the only spot, even to this day, that touches the water table. The rest of the structure is isolated. In an attempt to get to there, if you notice the niche in the Queen's Chamber, they call it the niche, is slightly off center by about 10 inches to the south, and the conduit on the south side, which again, both of those were behind stone, we drilled through them to get to them. The conduit that's on the south side is actually about 6 inches closer, and because the niche is also that direction, winds up being about 10-15 inches closer than this conduit. Now, it doesn't matter a whole lot, but electricity likes to take the path of least resistance. So if we have this going down to natural ground, and then we have this other conduit that actually shorts all the way over to the third structure, and the pool of water within the third structure, that would be, or they manipulate it to be, the path of lesser resistance. And when you give it the path of lesser resistance, it builds its potential to get to this ground, but then shorts to this ground, which is where it's captured and quarantined. And I don't care if you want to call it a power plant or just quarantining the natural, ambient, static electricity. Now this structure, the way it's designed, I told you this is a little ground here, it's designed to vent static electricity. This one's designed to quarantine static electricity. And this one, the way I said it was consistent, the whole body of it, it's designed to maintain a mean, average. Whatever static electricity is blowing around on this Giza Plateau, this one is going to maintain an average, this one's going to have an abundance, and this one's going to have a less. Whatever it is, whatever this is, this one is less, this one is more. So you are manipulating, naturally manipulating the structure that it wants to actually go to here, but it winds up going to there because this, I told you, shorts to there. Remember that? Shorts to there. So it's trying to take the path out. And just like a big circuit board, it will jump. The energy will go somewhere. At some point, it will reach its saturation, and electricity wants to dissipate to wherever it has less energy. Just like heat wants to dissipate to wherever less energy. Static electricity is no different, which is why you touch the doorknob on a dry windy day, you're going to get that zap, which is why when you pull your socks out of the dryer and you didn't put the anti-static cling in there, they stick together. Bed sheets do it too. Linens love to. Anyway, that's pretty much the system in a big nutshell. There's a whole lot more to it when we discuss get into how it's playing with the pressures within the system. Why this has a couple of different levels and steps is because within here, you're also generating a couple of gases. And if you look at, yes I do. There's a video I have of someone, but it's done on videotape. I'd love if we can get somebody, please share with me your videos. In fact, a Rilo, GoPro, I don't care. Share with me your videos so that I can give people pictures and images of this so it's not just my recollection. I want something I can share. I don't want to use what's stock footage out there because then somebody will yell at me for copyright strikes. I need something that someone donates to me, like the GoPro video I have, which was given to me with permission to share it with you. So it's there. I'm not trying to hide it from you. Within here, the gases, when you look at the roof line, so there's pockets on the roof line to quarantine the gases within here and manipulate them through the system. But what this is doing is it's acting kind of like the same way they have when you have an opening in a submarine underneath it so that a submarine can come into a boat, or inside a submarine, a smaller submarine can get into there and it still maintains a bubble. The gases that run along the roof line push down the water level, artificially making this water level lower in this system, which is why in this system there's the conduit that comes down into the system. They got a bunch of rooms, goes off to one side. It's got like six, I think it's actually 5 conduits that come off of it. It's all square. This is also kind of like a battery, just like the Serapeum. If you look at that and then look at the Serapeum, this is a smaller version of it. The Serapeum is a bigger version of it, but it's still where energy is stored within the system. The static electricity is quarantined to the surface of the water and the surface of the structure. Internally, static electricity, even normal electricity, doesn't ride through the copper wire. It rides on the surface of the copper wire, which is why when you bundle a bunch of copper wires together and make it like a twine, it actually carries more electricity than a copper wire. Just a thick copper wire doesn't melt as easy. And we can get into that if you really want to understand electricity and how it works. I have no problem sharing, and I have no problem learning. If somebody says, oh, no, well, the right amperage and the right ohmage and both, that's fine. But this is designed to do it organically without wires. It does it utilizing the conduits, and we didn't even get into all the rest of the conduits that are under the system and how it is working. But the basic thing is this structure maintains the water level for the system, and the pressures that be. It comes in, spills out, does not short. Everything is spilling in and spilling out so that the entire system is quarantined from nature. The water is coming down from here, also fill the pool that would be around the outside here. And it doesn't have to be 30 feet deep so that it goes up to this area. We dug down, when we found this structure, the thieves' entrance is up here, about 20 feet above what is currently ground level. But it could have been piled full of sand. It didn't have to be that deep. It doesn't have to be that deep to work. It just has to exist at that elevation to spill into the system. But it doesn't have to be deep. It just has to be up there. And it is fed from the higher elevation here down into there, and then runs through the system and runs out. And that is what feeds this structure. And it also feeds this structure. This structure, like I said, it doesn't have any moat or anything. You can look at it. It's a big, flat, open area. And I think when we really get into it, the size of the, it has kind of like a little wall that goes around it. When we look at the sizes of these, there's a lot of information that can be stored numerically and visually and relationship-wise. And if you really want to understand more about how their language, how their communication worked, there's a gentleman named Carl Monk who wrote a book and did lots of videos called The Code. In fact, you can get them at thecode.giza.ws. Or you can Google him, or he has books on PDF. He may have hard copy books still. I don't know if he still is among us or if he's passed over, but he was alive in the 90s, early 2000s. I heard a podcast where somebody interviewed him. I can't get in touch with the guy. I'd love to. I think he's brilliant. In fact, using his knowledge, we could probably dissect the rock garden up there a little bit more, as well as a whole lot more of the structure. And I think once you understand how the structure is working, the communication will make more sense. Like, I'm suggesting to you, there is hydrogen primarily within this room being joined from oxygen, air, actually it's air, from outside the system. Air being 21% oxygen, 78% nitrogen, and a bunch of other trace gases. It's the oxygen that burns together with the hydrogen that's pumped up from here, which burns together in where I like to call the combustion chamber, rejoins to be called water, and that water runs down through the system. And as this system works more and more and more, what I didn't get to, I skipped, and I'll touch it again. I was talking about the deuterium and all that stuff, 1.23 volts. Deuterium has a slightly stronger bond, and if I remember correctly, it takes like 1.33 or 1.25 volts. One of them, and again, it also depends on the pressures. Part of the way this system works is it's creating a lower pressure zone within the system, and down here it's creating a higher pressure zone within the system. And that probably goes to manipulate how easy it is or hard it is to break the respective gases. And also other things that occur in nature is if you have something that breaks at a lower energy state, but you force a higher energy state because of the way quantum physics works, you can step over the lower energy state to the higher energy state and actually force the higher energy state to break first because you hit it at the right frequency. And I will suggest to you now, and until I die, that water is a crystal. Water is a crystal. If you don't believe me, take energy away from it, it will freeze into ice crystals. If it falls from the sky, it creates snow crystals, very beautiful shapes. Crystals vibrate at an energy state. All crystals vibrate. I haven't found an exception to that. So whether water is in its liquid form or solid form, it still is subject to frequencies and energy states. That bouncy lady that does the TED Talk will tell you about the 71 different states of water, and she's only talking about the 71 different states of water at ambient temperature, at ambient pressure, ambient temperature. When you add more pressures and take pressures away, and with adding pressure and taking pressure away is going to be the same as heating it up and not heating it up. It all deals with manipulating the energy states. I think we can actually get deuterium to break before hydrogen. That's a guess, and probably when we work with this, it is most likely doing that because their goal is to get deuterium gas out of here to join together with the water to manipulate the system into making heavy water. And if you want to see the advantages of heavy water, you can Google that on your own. There are advantages to what heavy water does, and it may even be trying to achieve higher states. Maybe they have a secret there. One thing about nature, if you low energy nuclear reactions, if you create something to be at the brink of a reaction where it only takes a little bit of energy to cause the reaction, or you manipulate the environment so the reaction you get is more of what you want. And I can go into citing examples if you really care, but if you manipulate the system so that the reaction you get is not the normal reaction, but a better reaction, a different reaction, that can sometimes be referred to as a low energy nuclear reaction if you get it to the brink. The way we do it nowadays is we brute force it. I'll give you a great example. Electricity. 100 years ago, if I walked up to you with this, a solar cell, okay, you would say, what the heck are you going to do with a solar cell that creates 5 volts of electricity at trickle charge? Well, I'll tell you, we can charge our cell phones with it. We couldn't charge our cell phones with it in the early 2000s, not until the Apple phone came out. Well, no, actually, as soon as the flip phones came out. We could have probably done it around the 2000 mark. Prior to that, we weren't really using trace amounts of electricity. Up until we got the nanometer size processors that we have today, everything we did was brute forcing stuff. Everything we did was high amounts of electricity to get things done. Motors ran with high amounts of electricity. Nowadays, you can do a lot with a little. And if you don't believe me, I have an LED which I still have running that has been plugged in for about a month to a battery. Tried doing that 2 decades ago when you had light bulbs that used filaments that took a lot of electricity, or even arc lights took even more electricity. You had to get enough electricity to bridge the gap to create the arc. That was very energy inefficient. It worked. It's what they had at the time. Nowadays we can use an LED, and that LED can stay lit for days. You can have cameras, you have cell phones that'll last for a week off a little bit of a charge. So a little bit of power, we have gotten to where we can manipulate it to do a lot of work. When this thing was first discovered, we didn't even know what power was, but yet they were using it. We didn't discover heavy water. We really didn't start playing with heavy water until the early 1900s, when we started playing with nuclear reactors and stuff. That's when we discovered heavy water and what it can do. Before that, it was just a parlor trick, and even then you didn't know what to do with it. And even then it was hard to make it. So this is far, far, far from a tomb. This shows evidence of high knowledge, high tech. This may not be high tech, high knowledge. And it's pretty hard to dismiss. I could go on for hours. This thing is an awesome, awesome, awesome system. Please help me. I need the 100th monkey.